In this video, we'll look at inverse functions. For these, we're going to ask a few questions. Do they even exist? And first, maybe we should have said, what actually are they? And then the third is, if they do exist, how do you actually find them? Okay, so let's take sort of a cheesy example. Let's say that we have a blue set and a red set. We have some function which goes from the blue set to the red set, and let's say that that function is f. An inverse function is something that would take us from the red set back to the blue set. Okay, so if there's such a function that goes from the red set back into the blue set, we'll call that function f inverse, and we denote it f to the minus 1. Okay, so that's what we're looking for here. And then the idea is that if we did applied f and then applied f inverse, that'd take us exactly back to where we started. And we'll talk about the details of that a little bit more in class. But the existence question is something that we can say pretty quickly here. All right, so let's deal with that existence. How can you tell for a given function and whether or not it has an inverse? And what we're going to use is called the horizontal line test. And basically this is just like the vertical line test, except the lines are horizontal instead. Okay? So I'm going to take a graph here of some function, and I'm going to choose, say, a function that, we'll draw it here in a second, function that looks kind of like, say, x cubed. Okay, so I'll draw that in green here. So this function does have an inverse, and the reason is because if you imagine drawing any horizontal line, the question is, does that intersect the graph of the function more than once? Does any such horizontal line do it? And the logic for it is exactly the same as the vertical line test. It's just we're using horizontal lines. So all horizontal lines intersect no more than once, and so it does have an inverse. Okay, so now I'll sketch an example of a function which does not have an inverse, and I'll do it in red. So here's an example. And so this does not have an inverse because any horizontal line that I draw, at least the ones that are above the x-axis, intersects that parabola or that curve twice. And so just like with the vertical line test, it only takes one bad line to do it. This one has a lot of bad lines. So it fails the horizontal line test, and it will therefore not have an inverse. So we'll talk a little bit more in class as to the actual how to find them, and put in a bit more algebraic detail what I mean by what are inverse functions. And basically the idea for right now, though, that I want to get across is sort of what the relationship between f and f inverse are. They're both functions, and so they have domains and ranges. And if the domain of the first set is the blue circle, and the range of that function is the red circle, then what f inverse does is just sort of takes us backwards. Its domain is the range of f. Okay, so it takes us from, or if the f takes us from blue to red, then the inverse function should take us from red back to blue. This, by the way, is actually kind of a clever way of calculating ranges of functions for functions that do have inverses. So the how to find them thing is pretty algebraic, and we'll deal with that in class.